Okay, guys, we are doing lesson 1, 2, and it is segments and line segments and distance, I believe. So this is the 5-minute check that I actually wanted to point out to you. It says, which of the following statements is always false? Now, this is a kind of a common question that you'll come across in geometry, and there's, you got to reason and logic, all this out. But I just wanted you to read through these and see if you could figure out which makes the most sense, that it would always be false. The answer that is always false is there's only one plane perpendicular to a given plane. Okay. We are going to calculate with measures and find the distance between 2 points. And we're going to learn about 2 different ways to find distance. Actually, we're going to use the distance formula, which should be on your notes. And I'm going to correlate that with the Pythagorean theorem. And that is actually going to be a reflection question for you. So you'll want to pay attention. Line segment. I should probably grab the pen and write in purple. Ooh, neat. Undo. I don't know how to undo it. Oh well. Line segment has 2 endpoints. All right, it's been a while since COVID, but that would be kind of like a line segment. Betweenness of points is the weirdest term. It's really like distance, but it just means between 2 points. Same with the word between. Congruent is same shape and size, and it is this symbol here. It's an equal sign with a scribble on top of it. Something like that. You'll see that. Rigid transformation is when you can move a shape, and like if you reflect it or translate it, that slide, or if you rotate it. Rigid transformation just means that it stays congruent. It might be in a different location, but it's the same size and same shape, so it stays congruent. Congruent segments are 2 segments that are the same measure. We're going to do construction on Thursday, I think, depending on how this week goes with me being gone. And distance, I do want you to know that distance is always positive. Irrational number, that's not going to come up a whole lot here, but irrational numbers never end and don't repeat. So like the square root of 2, if you put that into your calculator, you're going to get a decimal that goes off the calculator. So it doesn't end, so that is an irrational number. And that's what we'll be dealing with a little bit today. So betweenness of points is just, they have a ruler addition postulate, I believe, that comes up later that makes way more sense than the betweenness of points. All it's saying is that segment PM plus segment MQ is equal to segment PQ. That's all it's saying. It's kind of just logic. So, using that idea, it says, assume that the figure is not drawn to scale. That is going to be a key thing all throughout geometry. You cannot assume anything is drawn to scale. Okay? And it says they want you to find the measure of xz. Well, they give us that xy is 4 5/8 and that yz is 2 1/2. So you just need to add that. And I know they're fractions, but you can put it in your calculator. You should end up with, 7 1/8? And there you go. Again, I'll let you figure this one out, but you're just adding them. Okay, here's where it gets a little bit, we're stepping up now a little bit in difficulty. You have to read and see what they want. So it says find the value of x and st. Okay, so you're finding 2 values. And then it helps if you draw this out. I recommend drawing it out, but I'm very visual. It says if t is between s and u, so I'm going to draw a not so straight segment. I'm going to make it very long, and we're pretending it's straight. So if t is between s and u, so we'll call this t, and this s, and this u, and it just says between. It doesn't say that it's an equal length or anything. And it says st is 7x, so this much here. And su, that's the whole thing. Wow, my drawing is great. Is 45. And tu is 5x minus 3. Okay. So we need to use that betweenness of points idea and know that 7x, so this part plus this part, so 7x plus 5x minus 3 is equal to the whole thing, which is 45. So 7x plus 5x minus 3 equals 45. This is the basic algebra that you will be doing. So it's not too difficult. This is what we did like at the beginning of last year. So 7x plus 12x, or 5x is 12x. So we're just combining our like terms. Then we need to add 3. And we get 12x equals 48. And we're going to divide by 12. And we get x equals 4. That is one of our answers, because remember they wanted the value of x. So x equals 4. And then they wanted the value of st. So st was marked by 7x. So now we have to plug that 4 back into that x. So 7 times 4 is 28. So st is 28. So that's our final answer. We answered the 2 questions. We drew it out so nicely. Oh, they did it too. They did it a little bit better. But they did the exact same thing as I did. Okay, so you can pause this and figure this out on your own. Try to draw it out. I will also do it real quick, or try to do it quick. It says find the value of n and wx if w is between xy. So I have xy, I have a w somewhere in the between them. wx is 6n minus 10. xy is the whole thing, and that is 17, and yw is 3n. So I will take 6n minus 10 plus 3n and add it so that they equal the full length of 17. 6n plus 3n is 9n. Now we can start solving. We'll add 10. 9n equals 27. Divide by 9, and you get 3. So n equals 3. And then we plug it back in because we need to find wx. So wx was 6n minus 10, so we'll plug 3 back in there. So we have 6 times 3, which is 18, minus 10, which is 8. So it looks like A is our answer. All right, congruent segments. Here's that symbol that I said means congruent right there. It's an equal sign with one squiggle on top. And also, if you are given 2 segments and they either have the same measure written, that means that they are congruent, or if they have, if they have this line right here, this red line, that indicates congruent. So when they have the measures or they have the line, you can assume the measures are equal. And then the distance formula, oh, this is a distance formula on a number line, which honestly, if it's on a number line, you can just count the distance. So I'm not going to go over that. Here's the number line. It says you're finding QR. So what they want is the length of QR, or the distance between Q and R. Now remember, distance is always positive. So you're just going to, you can count, and there's 3 spaces. So the answer is 3. And I know some of you are going to want to put units. You can write 3 units, but you don't have to for this. You can just write 3. Okay, so I'll let you count these out. Already you should have known it wasn't C or D, because distance cannot be positive, or I mean cannot be negative. It's always going to be the absolute value. It's always going to be positive. Okay, here I want you to highlight or circle this in your notes, okay, the distance formula. You're going to be needing this for more chapters than just this one. So it might be a good idea to kind of memorize it. It makes life a little bit easier. You don't have to. You can just write this on every chapter of your notes. It's totally fine with me. But what you're doing is you're finding the difference of your x's, squaring them, the difference of your y's, squaring them, finding the sum of those 2 numbers, and then taking the square root of it. So if you kind of understand how that works, usually it's easier to memorize. So it says find the distance between point E and point F. So we're going to use that distance formula, and I will write it out for you right now. So you have the difference between your x's, and it doesn't matter if you do x2 or x1 first. Squaring it, add it to the difference of your y's squared, and then you're going to take the square root of the whole thing. So if you need to stay organized, I would go ahead and say this is x1, y1. This is x2, y2. That's just to keep them organized and straight. Some people don't need to do that. Some people do. So do what you got to do. So we'll find the square root of, let's take x2 and subtract x1. x2 is 3. And we're going to subtract x1, so it's minus a negative 4 or plus 4. And then we'll square it. Add it to the difference of your y's squared. So y2 is negative 1. And you're subtracting 1 squared. Okay. So we have 7 squared, which is 49. And we have negative 2 squared, which is 4. And the square root of that. So you have the square root of 53. That is your answer. You can leave it like that, because that's an exact answer, square root of 53. Square root of 53 is an irrational number, so if you put it in your calculator, you will find that you will have to give an approximate answer. So it's approximately 7.28, but like I said, you can just leave it as square root 53. I think in my answer book I have both, maybe, possibly. Here's what I want you to pay attention to, because it's in your, it's for your reflection. And now it says to graph them and check by using the Pythagorean theorem. So if you, and you don't have to check them like this, but this is what I want you to understand. If you did graph them, graphing point E and point F, and then if you just kind of make it into a right triangle, and we're going to study the Pythagorean theorem way more in depth later on, but just so that you remember it, it's a squared plus b squared equals c squared. Okay? And it doesn't matter which of the legs are a and which are b, but, oh, I forgot the little squared up there. But the c is always the hypotenuse, or the longest edge. Okay? And this only works for right triangles. So wherever you have your points at, you need to make a right triangle out of it. So you find this length, which is 2, and this length here, which is 7. Okay? And then you fill it in. So you have 2 squared plus 7 squared equals c squared. And that's what you're finding, that distance there. Well, this is 4 plus 49 equals c squared, which is 53 equals c squared. And then to find out what c is, you'd have to take the square root. So c equals the square root of 53. Same answer we got using the distance formula. So the distance formula and the Pythagorean theorem are pretty much the same thing, and I just want you to explain that in your reflection. All right, I will let you try to do this one on your own. You can pause it if you want. You can use it, you can do it the Pythagorean theorem way, or you can use the distance formula. It doesn't matter to me. Since it's drawn out, Pythagorean theorem might be easier, but maybe not. I'll let you practice it. You should have got square root of 20. Oh, and then I think, I don't know. Well, we can go through it a little bit. It says Josh is standing at the 30-yard line, 15 yards from the sideline when he throws the football. Johnny catches it on the other team's 20-yard line, 5 yards from the same sideline. How far did Josh throw the ball? Well, essentially, we have 2 points right here. And you have to have some knowledge of a football field in order to understand this. So here's the picture. And they're using this kind of like, like this is your coordinate plane. Okay. So because Josh is on the 30-line yard, if this is where your origin is, that would actually put you at 70. So they have the points 70, 15, and 25, and you're just finding the distance between those. So you can put those into the distance formula, and I'll just kind of do it real quick here. So we'd have 15 minus 5 squared, or 100. And then 70 minus 20 squared, so that's 50 squared. 2,500. It took me way too long to figure that out. And then you'll add them together, so you have 2,600. And then find the square root of that, which is about 51. I used a calculator because, yeah, approximately 51 yards. So, and you could also use the Pythagorean theorem if you wanted to draw it out here and just find the distances of each, or the length of each leg of the right triangle. Here's they're using the distance formula, so you can kind of see how they did it. And again, it doesn't matter because you're squaring them. It doesn't matter if this is your x1, y1, or if this is your x1, y1. Either way, it will work out as long as you're entering it to your calculator correctly or doing the calculations correctly. Blah, blah, blah. All right. So if you want to read this and do this, try this one out. You can. It is answer D. And that's the end of that. I have no idea how long I've been recording. I don't know if it'll tell me. I have your assignment, or Mrs. Muslin has your assignment, and it's on Google Classroom under my lesson plans. Also, there's a reflection. I think I'm going to have tomorrow, Tuesday, be a work day because it's picture day, and I'm not sure if there'll be pictures in the afternoon. So if you just start working on this and doing, or just want to do the reflection, that's fine, or work on the assignment, that's fine, whatever you want to do, and then tomorrow finish it up. That way I'm giving you plenty of time to work and check your answers. Mrs. Muslin has the green Bible notebook, and yep, and then Wednesday I'll have a new lesson for you, and then I'll be back on Thursday in which you can ask all the questions you want. So thank you. Have a great day.